And I think we're live. Welcome everybody who's tuning in. Today we have Pete, which I'll let him introduce himself in a second, but we're going to be talking about the edge, which I think is particularly fascinating. It's a new world. It is navigating sort of limitations of physics we've been dealing with about, how you deliver applications quickly when your application maybe today lives in one place in the world and your users are in another place in the world. You could say, oh, just put the application at the edge. And it's like, well, what about the data? What about the API services you're using? What about the frameworks and their capability to render quickly at the edge? There's a million things. But as sort of Cloudflare and other providers are exploring what can you do at the edge with the server-side rendering, with the application performance, how do we handle data? And as people are running into limitations of the current structures that we're sort of bound to and how we deploy applications today, there's a lot of new research going on. There's a lot of stuff that is really exciting that Cloudflare is working on. There's a lot of interesting stuff that Quick is working on that plays really nicely to it. And so anybody tuning in, please just throw questions in the chat. We have some topics we're excited to talk about and sort of introduce you all to, if they're new to at least some of you, I would guess. And so whale on that chat. And with all that said, Pete, welcome. Please tell us about yourself and the work you're doing at Cloudflare, and we'll start digging in from there.
Thanks, Steve. Thanks for having me on. So I've been around in the industry for quite a while, and I've been sort of on the conference scene a few years, mainly in the Angular community, because that's how I know you and Mishko, because I used to actually work with Mishko on the Angular project, and we had many wonderful years together. And I was just thinking about how it's been a really long time since I've been on any sort of external podcast like this, because when you're in the Angular community, you're kind of doing this sort of stuff all the time, and then you sort of drop out and it all kind of goes quiet, and I've kind of forgotten what it's like to be on a podcast. So I'm really excited to actually get back into this. So yeah, my background is that I spent the better half of a decade working on Angular, on the Angular team, but then this summer I decided it was time to try something a bit new. And so in December, I actually moved to Cloudflare. And the big thing that I was really excited about with Cloudflare is this concept, or this application that we have called Cloudflare Workers, which you touched on a little bit, Steve, which is where we actually have this amazing network that's spread across the whole world. That's only a few milliseconds away from 95% of humanity. And we can actually run code on those servers right on the edge of the network. So rather than having to go all the way back to some centralized like origin, we can actually run people's code really near to wherever the browser is that's coming in. And I thought that was just an amazing opportunity to change the way that we build web apps and the way that we can actually interact with the user. So I joined this team called Experiences, and it's all about experiences for the user, experiences for the developer, experiences for us on the team, and trying to make those as best as possible. And in the last few months, I've been focusing with a team which includes Igor Minar, who's also from the Angular team. And we've been looking at ways of thinking about how we could maybe use current frameworks or work with frameworks or look at new frameworks on the front end to actually make the most of what we can offer in the sense of running code at the edge. And there's so many potentially new areas that we could open up to do with SSR at the edge, which allows you to stream things down really close to the browser, so that things can just happen much more instantaneously. You can then actually just stream the data that you need as it's needed, rather than having to try and batch it all up. You can have much more close interactions, so you can move code away from the browser and into the edge, so you're not having to download as much code to the browser. And all of this is sort of starting to crystallize into some ideas that we have around micro-frontends, using like a whole cloud of small workers that all work together to construct web apps. And we've been looking at lots of different frameworks, and certainly one of the ones I'm most excited about in terms of this that could support this is the Quick framework. So I've then had lots of chats with Mishka and Manu about what the quick framework does, and they've got lots of ideas, and we've been sort of bouncing ideas back and forwards. So it seemed like a good time to come and talk about that in a bit more detail.
No, that's amazing. And this is really exciting. I mean, I would say, in my experience using CDNs, I mean, originally was, your application's at the origin, the CDN might do some basic caching, right? And that's nice. That helps your origin servers, handle load a little bit better, and users can get cached responses faster. And then we're seeing definitely more and more people doing lightweight scripting of the CDN. In fact, we've been doing that builder for quite some time. Whether you're just kind of tweaking URL parameters or headers or doing some simple traffic splitting, an A/B test or something. And that I'm seeing starting to take on more adoption, and services are supporting that better too, right? Like Builder has some good integrations with these providers where you can just be creating content, choosing what people see, what content, test groups, etc. And the Edge splits it automatically. Everything's amazing. But what's really interesting is what you started to hit on is, well, what about putting your full application at the Edge, right? And that's where things seem to be moving. And that's where we get all these additional benefits where we're not just splitting cache keys and still going to origin service or cache misses. Everything is there. What's especially interesting, though, and this is relatively new to me and I think is fascinating, is this idea of the multiple workers. I think it's pretty unique. I've never seen anybody experiment with this or talk about it besides you and your team at Cloudflare. And I think it's fascinating. I have to admit that micro-frontends always seems like a cool idea to transfer the benefits of microservices to the front end. We use microservices for our back end, and it's amazing. You have one tiny function, you deploy the function, there's not side effects, you don't have to worry about what else could change. You test that thing, you get it live, you can iterate faster. But then, like in our case, our gigantic web application is, you better test everything. The smallest line of code change could impact something else. It's all deploying at once. So this idea of multiple edge workers, you can make small deployments and they orchestrate. Can you tell us more about this? Because this is fascinating the more I think about it.
Yeah, so here's the thing. We've been thinking a lot about micro front ends, and there are various sort of ideas out there at the moment, including like batching up your code with sort of module federation and that kind of thing. But what a lot of it comes back down to, which is things that Mishko has talked about before with frameworks which are running JavaScript to render the code in the browser, is that you end up having to download a lot of code. And if you want to start breaking up into micro front ends, then either all those front ends have to be guaranteed to be working with the same framework at the same version so that they can share code, or each framework is going to have to download like a whole each micro front end is going to end up having to download like a whole framework to go along with it. And that's going to add even more lag and make everything slower. So you're trying to break these applications up into smaller chunks. And the motivation for that is maybe to allow your teams to work more independently, to be able to deploy independently so that you can actually turn around features faster. But you end up having a worse user experience because each of these small micro front ends is bringing along a huge amount of baggage. And so one of the things that we were thinking about, which would make a massive difference, is if you can actually SSR stuff more at the back on the server and shake out. Oh, the other thing with like federation is that it's really hard to shake out code, right? Because you don't know what's going to be needed. So you have to bring everything with you in case some of the micro framework front ends are actually needing that code. But if you can shake it out in an SSR scenario and only download the code that's relevant to that micro front end, then you effectively can bring a whole framework with you for each front end, and they can be completely independent, and you can have different versions running because each one only has the code that it needs in order to do its job. And this is one of the areas that we think is really exciting, because by moving away from having a big monolithic JavaScript app to like lots of small ones, not only do you get that deployment freedom, but also each of those could independently be streamed down into the browser, and you would get a much faster time to first byte or time to first interaction, because while you're waiting for some of the slower fragments to come in, like I could talk about fragments in terms of these micro front ends, the other ones can be up and running, and you can be interacting with those straight away. And so you get this sort of perception of really fast load of the page, while some of the less important, more data heavy things are kind of loading in the background. And we've been chatting a lot with the Quick team about how that can work, and they've got some really cool ideas. But also, just in general, breaking this up means that you can spread the load in the server. So the idea that we have is that each of these Cloudflare workers could be independently responsible for their own micro front end. And then you might have like a gateway worker that then patches them all together and streams them down to the browser. So what you end up with is a big parallelization of the actual work that's going on. And you can scale it out. So like the more fragments you want, the more servers just come online, and potentially we could maybe build something where the developer doesn't even have to think about that. They just deploy to the cloud, to the edge, and then there are some number of workers that are then brought into play in order to achieve this kind of fragmentation. And this is the area that I think is going to be really exciting in terms of pushing the boundaries of how quickly you can get a page up and running, how quickly you can have the perception of interaction for the user. And one of the nice things about Quick is that it's really great at serializing its state and dumping it down into the browser and then resuming it really quickly without you having to have this delay. So we can actually do things like have multiple micro front ends which are each their own Quick app, and then stream them in. And as soon as each one has appeared, it's immediately up and running, even while the other ones are downloading. They don't have to wait. And we've managed to put a few internal demos together that have tried this out, and it's starting to look really exciting.
Yeah, this is fascinating. Let me give a really quick recap. Okay, go ahead. You can come in.
No, I was just gonna say, like, I'm super excited about this idea that you can, while the app is streaming, which means like it's still in HTML is being delivered, parts of the app has still not been delivered, in other words, are missing, and yet you already have interactivity on the page. And I think that's super cool, fascinating, etc. And it kind of points out that like the prerequisite for that is that like if you have hydration kind of requires the full page is fully rendered, etc. Before the hydration can run, right? And so the magical bit here is that like we can do this even when the full page is not available. And I think that's super cool.
Yeah, let me, I really want to give it a recap just because we're talking about multiple workers. I want to paint a picture so people know exactly what we're talking about and verify it. And then, yeah, Mishko, I'm going to want to go really deep into the weeds because there's going to be some interesting stuff here too. But just to paint the high level picture briefly first, just so people understand, and Pete, you correct me if I have the wrong mental model. The main idea is the entry point to your application will have to be one worker, right? But that worker is just orchestrating out to other workers. So think of that as like Quick calls it containers, Marco calls it fragments. It sounds like you all use the terminology fragments, same whole idea. But that could be broken up into small sub applications, however the framework does it or however you choose to orchestrate it. And then, yeah, page, request comes in, and then we assemble pieces which can stream as they're ready. And I never thought about the parallelization benefits of those things running whatever business logic needs to happen concurrently, essentially, or I always get in trouble for using parallel concurrent wrong, so forgive me. But basically, those things would be running at the same time, speeding up your application. It seems to me that this has benefits to, and I have to be honest, micro-frontends never appealed to me for the longest time. I kind of rolled my eyes. I just didn't think it'd be possible. It seemed like a pipe dream. But now with this approach, it makes so much more sense to me personally, and seeing what's going on with quick containers, micro-fragments, etc. These SSR first sort of methodology, so you're not loading up too much JavaScript code to orchestrate this. Seems like it has benefits to resilience, like you could use feature flags to deploy pieces and roll them back or roll things out independently. Like one thing that happens a lot is people just want to get a new page live, but they don't want to break any other page of the application. Cool. That can be its own micro application. I do think Quick's exploring some really exciting stuff to make it so that the developers don't have to think about this. Like they're building applications and it, like you said, Pete, you build the application, deploy, and it actually shreds and runs. That's all Quick's whole thing is shredding your application into these bits that can resume as needed. But it has benefits for personalization. You can be pulling certain pieces that actually are grabbing different content from cache or generate on the fly. It has benefits to performance, like we said. So cache containers go immediately and slower ones stream in out of order, etc. What other benefits do you see? What are some of the other use cases that are most top of mind?
Well, I was just thinking when you mentioned feature flags, there's a really interesting thing about when you start moving the code off the client and back into the server, that you actually get control over that code, and you don't necessarily have to give people visibility of it. So a really good example is, like, let's say you have a feature flag that you want to turn on for some people. If you're doing that in the SSR side of things, then if that feature flag is turned off, that bit of code never runs. But more importantly, it never even gets down to the browser. Like at the moment, if you've got client-side feature flags, you still have to dump all of this code that's never going to be run. So not only is it wasteful, but you're also like exposing the feature to the world, because that's what happens with JavaScript. Whereas as soon as you can move that back behind the fence of the server and into the edge, you can actually start doing really cool things where you only need to give down the code of the flags that are turned on, but also you can start doing more sort of security sensitive things in that code, knowing that it will never actually make it to the client. And I think that that's another really exciting aspect of SSR and shaking out code that's not used or not wanted from ever getting to the browser. So that's one thing. The other thing that I think is really exciting about fragmenting into these pieces is that not only do you free up the deployment of these apps so you can deploy them independently, but also you can use it as a kind of migration strategy. So we've been looking at, like, imagine, say, you've got this huge monolithic React app that's just one massive client-side app, and maybe it has some lazy loading boundaries or something, but fundamentally you deploy the whole thing and it all is going to end up in the browser. And you want to start moving to a more kind of lightweight, multi-worker, micro-frontend approach. Then what you can start to think about is, like, well, maybe there's just one page or one part of the view which can be turned into a micro-frontend. And perhaps you would then create that micro-frontend as a quick container and then inject that into the whole app. Now, it's not really much use if you're doing that on the client side, where you have to still wait for the whole React app to boot up, and then it goes and gets the quick app, and it has to then download that. And however fast quick is, it's still waiting for the bootstrap of the main app to actually allow it to get on with its stuff. So what we've been looking at recently is an idea where if we know that there's a component that's going to appear inside, say, a React app at some place, we can stream that down to the browser first, kick it off, let that start running and be interactive. In the background, we're downloading and bootstrapping the React app. And then when everything's bootstrapped, we then take the component that was initially streamed and move it into the right place in the DOM so that it all starts to think that it's one app again. And we've had some really good fun demoing this. Like, we had this login page where the actual login form becomes a quick container, but the rest of the component, the whole app, is just a React app. And then you can slow down the server and have it really, really slow. And the quick form just appears on the page instantly, and it's interactive. You can start typing in. You can't actually log in because the actual machinery for doing the authentication is part of the React app, say. But you can start interacting with that, and it can give you validation and so on. And then in the background, the React app boots up, and it then grabs the DOM of the whole quick container, moves it into the right place, wires up all the events, and then when you hit the button to log in, it then triggers the actual machinery to log you in. And we can even queue up events. So if you do start hitting the login button before the bootstrap of the React is completed, we just queue those up in a buffer, and then once it's all finished, then it floods it through. And the experience for the user is fantastic. You go from a situation where you go to the login screen, you have a spinner for 2 seconds waiting for everything to happen, and then finally you get to log in, and this is your first experience of coming to this app, versus you go to the page, bam, there's an input box, a button, you can start typing in, and by the time you've done that typing, the rest of the stuff has booted up, and you never even noticed that the rest of it was slow. And this can be done without really having to make a huge change to the overall application that you're migrating from. And I think that this is a really exciting way that we can start to migrate people towards these kind of micro front-end approaches. And because Quick is so nice at being self-contained and doesn't need to have stuff outside of the actual DOM that you download, because it's all the data that it needs, it's a really good example of doing that. And I'd like to see other frameworks like following on with this, because it would be a great way to be able to give people options. But obviously Quick's leading the way in this case.
Yeah, I'm excited to see the two that I think have the most potential to be helpful here are Astro and Marco. Anything that's SSR first and kind of has this like general notion of islands or containers. I guess Fresh could maybe do some things here. Mishka has a whole thing about working on one of these frameworks like Angular and being so hard to add to the existing sort of methodology, which we could touch on in 1 second. But yeah, I mean, this is fascinating in particular because like one example we had in the earliest days of Builder, I made this gigantic React application for this whole drag and drop, all this stuff, personalized tool. And we're like, oh, we got to spin up our homepage. And we're like, that's okay. React can code split. It's fine. And you make the homepage. And this homepage was slow as heck because you just didn't realize you made one little import that imported the whole world, right? And when the entire application really is this monolithic unit, it's problematic. And so this is a good time. Apologies, we had a lot of preamble before we can get to you, Mishko, but this is where I think it was like a happy surprise. Like, you know, Quick was trying to tackle a certain set of problems, and another set of sort of challenges people are facing in the ecosystem started to crop up. And we started going like, oh, Quick could do this really well. You know, this very different approach had these advantages. Mishko, I'm curious your take on effectively everything that Pete is saying and how this is marrying well with this sort of idea of just like streaming HTML first, resumability later, and how that like surprise is fantastic for micro-frontends and personalization and everything that Pete is talking about, and orchestrating other applications from other frameworks, which is another surprise too. So I'll shut up now, let you jump in.
Yeah, I think if you look at history, how we got here, I think we got here into like the way we build web frameworks and web apps from desktop world, right? And in desktop world, you make certain assumptions like all the code is available to you, or fetching the code is not expensive because it's on the disk. And I think these assumptions just kind of implicitly transferred over. And existing frameworks, when they finally said like, oh, we need to do lazy loading, they did it as a post hoc input. And because of that, it does, I mean, it sort of works, but it doesn't really like work all the way through. And the other thing I kind of noticed is, and I'm guilty of this as well, is that at first when I started thinking about lazy loading, I was like, well, we just like create boundaries and it's okay. Not realizing that in the real application, the graph is so intricately woven that like putting things out is actually way harder than you can possibly imagine. Like you think that you put a lazy load boundary and you're good. And then you realize like, well, no, there's all these other secondary dependencies that cause the system to download this piece of code, right? And so you really have to look at it from the other end and say like, no, we start from the other extreme, right? We start from the extreme like we have no code, we have no, everything's lazy loadable. And then how do we design the system from that end? And like that's just a kind of the basic way of thinking about it from the quick basic principles, right? And everything else just kind of follows. And I think that's kind of what makes this huge difference. The other thing that you kind of come to is that you need a form of serialization, right? The fact that the Quick application is just pure HTML it clearly has a beginning and an end, and as long as you have that piece of HTML, the app can resume and continue. That makes things like the edge workers or the composability or having multiple pieces of the page and then merge it all together. That's kind of what makes all these things work easily.
Yeah, go ahead.
I was going to say this serializability is actually really exciting, and one of the things that Manu's been like talking about in our chats is this idea of with Quick, you don't actually have to think of it as a two-step process. Like it's not SSR and then running it on the client. It's like, well, when I'm doing SSR, I'm just running the app. It just happens to be in a worker, right? And then I'm going to pause it at that point, serialize it, send it somewhere else, which might be the browser. And then at that point, the browser says, right, I'm going to restart this app. We're going to carry on program processing and so on. But actually, you can take that to a bigger extreme and say, well, actually, why does it have to go to the browser, right? If I'm serializing it, that's just like freezing the state of this application and it's ready to resume. So maybe what I could do is have a very blank, dataless SSR where I just kick off SSR, render the app as far as I can, but without any real data, and then freeze that and cache it because you're only ever going to have to run that once per deployment, like, because the only reason that would change is if you actually change the code that you've written. So that's cached basically forever. And then you then have another layer where you say, okay, now I'm going to grab that cached frozen application on the server again in another worker, run it a little bit more, but this time I'm going to inject a bit of data in. So maybe I can inject the product data from the back catalog, and so therefore I can now on my page show some product items, and then cache it again, right? Freeze it, cache that, and then that cache only needs to be busted if the data for the products changes, and that's going to be more often than deployment maybe, but not like super often. And then finally, when your user comes along with their browser and says, hey, give me this page, and by the way, I'm Pete and I want Pete specific data on there, then you just go and grab that particular product page which you've cached because it's all serialized, pull it out, run it again a little bit more on the server, add in the data that you know that you can render more stuff because it's Pete, and then finally push that down to the client onto the browser, and then allow the browser to then resume it. And so you get this amazing idea of like layers of caching, and each layer could be declaratively set up. So you wouldn't actually necessarily as a developer have to think too hard about this. You would just sort of say, this stuff needs to be cached for this, like based on this data, and this needs to be cached by this. And then we could build some kind of tooling that would just deploy these workers again in a way that you don't have to think about. And you just know that when you ask for this page, it can then decide, okay, I need this bit of data and that hasn't been cached, like the version of that hasn't been cached, so I'm going to have to run this bit, but I'm going to go and get it from this bit which I know has been cached. And you get this big speed up. And again, this is one of those things that I think we were talking about offline, about one of the problems with trying to make things run at the edge is that you've still got the data is like a long way away. It's hidden in some centralized storage. But if you can do this kind of layered caching, then it saves you having to make those calls back to the central database and speed up that bit. And then maybe you can sort of have something, for instance, with if it's a user-based data, that's going to be very localized to the person, to where that person is in the world, because people don't tend to exist in multiple places at once. So you could then somehow pull down the data that's relevant to that user and just store it locally at that point in the edge. And that way, you get that data really, really fast. And so suddenly you've gone from a situation where previously you'd have to hit your server, the server would then have to go to the other side of the world to ask for a load of data, wait for it all to come back, then build the entire app in an SSR container, which is slow and heavy and it uses lots of resources, and then finally dump it down to the client, who then has to rehydrate it by running the whole application again. If you think about all of this wastage that's happening, it's amazing. And then now we're on the cusp of having a situation where the data is available when you need it. It's cached as much as you can, and you minimize like as close as you can to the actual the cost of actually going from I want to see this thing to having it on the screen.
I think you're touching up to the problem of personalization, right? Personalization is super hard to do, and most e-commerce websites don't do it in a kind of a good enough job, specifically because the only caching mechanism we have is on the page level, right? And the moment you want to put person's name somewhere, you are invalidating the whole cache, yet most of the page is actually the same. And so the whole trick to personalization and being performant is like, can we take the page that we have and break it up into smaller chunks and then cache the individual chunks separately, right? So every single person that comes might have different preferences, and therefore you want to show them a different hero image, maybe shoes, maybe 3D printers or whatever you're into. But at the end of the day, there's a limited number of like prototypical users that come to our website, and therefore there's a limited number of hero images that we show them, and each one of them can be cached separately. All we need to do is figure out, like, for this user, which one of these pre-cached images do we have to show them, right? And by breaking this up into smaller chunks that can all run on a separate edge worker that have their own separate CDN, you can really speed up the result of the application, because as you pointed out, right, you're no longer talking about a one level cache and nothing else. Now you have many, many different layers of caches, and they can all become better because by having smaller chunks that they're caching, they're more likely to have a cache hits.
Yeah, I was chatting with someone about this idea yesterday, and they're like, but this is really hard to reason about, right? Like, imagine like if you're trying to get like this page and you just don't quite know where all the bits are coming from. And I thought, well, that is true, but then think about what Quick has done with like breaking up code into tiny pieces and then package them up. You know, that's really hard to reason about as well. And it still blows my mind that you can have a compiler that can break your framework up into a billion pieces and sort of makes them available at the right time, and the closures all work, and you know, all of the pieces just hold together. Like when you think about actually trying to build that yourself, I'm always really impressed, because I'm just thinking there's so many ways that could go wrong, right?
Oh, thank you.
Yeah. Maybe it could still go wrong, but you know, you get the idea. And I think that this is another place where clever frameworks and clever tooling take the pressure off the developer, which so we often talk about user experience because that's what drives good Google ratings, which drives money and so on. But at the same time, if the developers can't build the app, then they're not going to bother, and then they'll use something else. So the user loses out as well. So I think a good developer experience is still key. Whatever people say about user experience being king, I think developer experience has a big part to play.
Developer experience is very much a key. But I think we're living in this weird world where developers, they don't really necessarily directly feel the pain of a slow application, right? Because they're on a desktop, they're in a fast network, etc. And so we have this kind of recipe for disaster, right? We have developers who don't feel the pain. Who feels the pain is end users. And whenever you have the situation where you are the source of the problem, and I'm not saying developers are the source of the problem, right? But where the source of the problem is not directly aligned with the person who can actually do something about it, right? It's just a recipe for disaster. And so we live in this world where we have a nice DX experience, right? So developers love the DX experience. They love building the apps the way they're building it, but the slowness is felt by the end user. And by the time the company says like, well, we need to do something about this, right? It's kind of too late because so much code has been written and things are hard to move around, etc. And I'm actually going to go a step further and say, actually, you actually don't have as much levers as you think you do, because the framework sets the game, right? The framework basically says, these are the rules and you all have to abide by it if you want to use this particular framework. And as a result, there's very little the developers can do to change things, right? Like a framework says, I require hydration. And as a developer, you're like, well, I guess that's what we're doing because like there is no other option. My only other option is not using this particular framework.
I talked to some engineers at Priceline one time. It was clear one engineer had gone so insanely deep on how do we manually do this? How do we add dynamic imports everywhere? How do we abuse suspense to death? Like, how do we just try to get better performance out of this current paradigm of full hydration upon application delivery, and basically met with the result of it just doesn't work. There was actually no happy balance that could be found. And it's obviously, I mean, we talked about Quick and stuff like that too, which I think is fascinating here. And I think I want to jump in with a question that came from Tito. So let me try and give a pass at this. You all let me know if you agree. But what I think is interesting about this is how our backend works. And our backend now is so much easier to deploy than our front end, because our backend is a bunch of serverless functions, and one function calls another function, and it's a sort of tree, and each can have their own caching layer, which is fantastic. And you could use things like surrogate keys to invalidate things when you need, which is like idealistic. And it is crazy to see, and maybe not shocking, that our backend in this way is so far ahead of our front end. And I love what you were saying. I mean, you were talking about like tracing these things. I also don't worry about that as much. I mean, we all know that caching is one of the hardest problems in computer engineering, computer science, right? But also, like, we had this same problem on our back end, and we set up, I forget what Google's distributed tracing system is, but it worked phenomenally. You can basically, trace everything, and just a little bit of headers, a little bit of metadata sent with each of the responses allows you to actually, there was a really good tool for this that made it quite easy, actually. So we could trace everything down to the database calls, et cetera, and where we got cached, where these things executed. And I do think, I mean, because Quick serializes to HTML, we can add a little bit of metadata in the HTML to say who rendered this, when, why, how, etc. And you could sort of replay and do a lot of really interesting things from there, which I think is exciting. And I think, that's just extremely similar conceptually to what we're talking about here. But I do want to confirm, is that sort of the right conceptual mental model? Is what I'm gathering from Tito saying sort of a lot like you're kind of seeing things, Pete?
Yeah, I think so. One of the struggles I am having at the moment is how isolated are these micro frameworks, because micro front ends. If they were completely separate from each other, then life would be really peachy, right? Because you can really think about that structure, and as you say, you just look at that point and then the rest of the tree down, and it's all contained, and you know exactly how it's going to work. But looking at real world applications, there's obviously never a perfect world where each thing is completely independent. They need to know about each other one way or another. And I think that this is an area that still needs a lot of research to decide what would be the best APIs, what's the best contracts, how much freedom should these micro front ends have to modify other people's data? Like, how would they go about doing that? How much do we want each micro front end to have to be designed knowing that it's a micro front end? Like, could we be able to design things so that you just build it as though it's like a mini app and it just happens to then fit in? Or do we have to actually build it in a way where it knows, like it's like a bit like the whole enterprise Java Beans world? Do you remember where you had to add all these wrappers and things, and it totally knew that it was a bean, and that really constrained how you built it. So I'm thinking a lot at the moment about where that contract is and how far you can push it and how generic you can make it, so that, in our world, potentially we might have micro front ends mixing with quick ones, or especially if you're having a migration from one framework to another, you might end up having separation of frameworks, and you need them to be able to coordinate with each other in a fairly generic way. And I know that Quick has got some ideas about how to do this in a way that's fairly agnostic to the framework, but I think that it's still a fairly nascent area that needs a bit more thought.
I love this idea, because if you look at a typical page, right? Let's take Amazon like an example, right? On the top, they have a menu system, right? And below it, there's usually like a header, or if you're on a specific product, then you have a product. And below that is like description or featured products. And below that is comments that people leave on the products, right? And if you think about it, all of those could be separated out relatively easily to separate teams, and to separate individual separate teams, and also like separate caching, etc. Because like the menu system doesn't change that often, right? Like you probably just give everybody the same menu system. The commenting is really separate from the product itself, and it can be a separate team that works on it and has separate SLA and separate constraints about how fast it has to load and that sort. So I feel like our UIs are already kind of have natural boundaries that naturally break up the app into smaller sections. And then each of those sections can be given to a separate team that has its own separate edge worker, that has its own separate caching strategies. We just need a good way of merging all of these things together when the request comes in.
Yeah, I mean, also at the end of the day, right, this is where I still am a fan of, just the general idea of functional components in React. Just that simple, UI is a function of the, inputs that came in, right? And I think about the serverless functions analogy too, is that, right? Or really, it's kind of like the UI functional component world and the serverless world are merging a bit, right? The functional component world, which is what Quick is sort of built off similar mindset. Yeah, you have the function that's a function of its inputs, and you have context, right? So it's the other piece. And Quick obviously can do that orchestration for you. It's interesting to see the new Preact signals announcement and like talking to Astro about, can signals be a shared state mechanism? We'll probably have pros and cons compared to sort of Quick's methodology. And serverless functions are similar, right? In the sense that the context is essentially whatever is persistent, whatever you're sharing over Redis cache or a persistent database or something. thing. And then keeping in mind that idea of orchestration and all the caching, like I'm imagining, maybe Quick needs this, maybe a third party should build this, something that can provide some type of layer around your calls. Like I'm imagining you're building a front end, and you gave the example, I think, Pete, of like the product data becomes part of one of the containers or one of the fragments, right? But you're going to want to probably observe, like maybe somebody can install to Shopify's webhooks to observe that the product changed, maybe a surrogate key or something. We can invalidate that data, invalidate the front end that attaches to it. Maybe this will get crazy. I'm not entirely sure if this will become a large, elaborate, challenging thing. But I think that's where we're sort of like incrementally like prototyping to see, conceptually, how do these things fit together, and how does this transform into large production, and kind of figure that out organically. But I'm curious, Pete, you want to jump in anyway, but like, yeah, exploration here is really fascinating. I know you've done some.
Yeah, so one of the things that I've been quite interested in is with respect to workers particularly, is that we talk a lot about interaction between micro front ends within the browser, but actually there's a kind of a slightly bigger picture, because when you start thinking about the edge being super, super close to the browser, like literally tens of milliseconds away, that the user can't even perceive that time difference particularly, you can actually start doing interactions and communications via the edge. And I think this opens up a whole new frame of reference. Like we're all really used to nowadays these sort of interactive, collaborative environments like Google Docs, whatever, where you're typing and someone else is typing and you're all collaborating together. But the opportunities of being able to do that are, when the edge is so close to you, is suddenly opens up a lot more options. And it's not just about collaborative documentation, but also if you've got third parties that you're communicating with, maybe what you do is you have the data coming from the third party and being cached locally at the edge, and then you have like WebSockets that allow there's a direct connection between the browser and the data that's at the edge, so you can start having much faster interactions there and updates in real time. I think that there's an opportunity there, and I think that this also is a way to consider, like, not just using sort of global state in the browser to share data or whatever, but actually maybe pushing it to the edge and then sharing it, and then you get the opportunity to also share with collaborators nearby as well. I think that was a bit off topic from what you were talking about, but it was just something that was kind of popped into my mind while you were talking. And I think that this idea of moving data to the edge is a problem that needs to be solved, and it's a hard one, and because you can't have consistency and general availability, right? So either the data is in one place and you guarantee it's there and it could potentially take a long time for you to get to it, or you share it around, but then potentially it's inconsistent in different parts of the world. And I think that this is, alongside the challenges that we're trying to achieve with breaking up front ends into micro-frontends and caching and so on, trying to work out how to get this data in the right place at the right time is also part of the plan that we need to solve. Cloudflare's got a few ideas about this, but it will need to have like integrations with frameworks, and I think there's almost like a paradigm shift about how you get data and consider data in the front end that needs to change in order to make use of that sort of thing.
So what do you also, I mean, yeah, I think the most exciting thing here is, honestly, there are times where I think the web paradigms are established. We figured it out. We did the thing. And then everything changes sometimes. It's like, never mind. I wonder sometimes why the web's so crazy like this, but you get it. I mean, you said it. I think, Pete, you have hilarious quotes. I wrote one in here. People don't tend to exist in multiple places at once, like Schrodinger people. And he said another one about just something about like when UX is better, money goes up. I don't know. You said it, you phrased it so well. I wanted to jump in the chat and type it. But yeah, I mean, that's the reality. Deliver richer applications faster, and you do it a certain way, and then it hits a limit and you find a new way. And once you find a new way, this whole new green field sort of opens up, and it's really exciting, actually. But I'm curious, this idea of these distributed multi-edge worker micro front ends, do you see it as, like, I'm trying to think of who and when, right? So I'm curious your thoughts, and I apologize, I'm kind of weaving two questions at once, but I think a single answer might be fitting. Is, is this ready for people today? Who is it ready for? Is this more a tomorrow thing? Do you imagine a world one day where, yeah, every application, like if you're just making a personal blog, are you going to just code it up in a simple way, hit deploy, and just blam, you get all these benefits? How do you see this sort of realistically on the who, how, and when?
I mean, this is very much in your ballpark, isn't it? This idea of taking complex things and trying to make them simple to use. And I think that that's the key, right? So ideally, the web should be open to everyone and should be available to everyone. And this is one of the big goals of the Angular project over many years, was taking a really hard thing, which is making a big application that works fast and can be maintained, but making it so developer friendly that most developers don't have to apply too much thought to actually using it. They can just follow good paradigms and they get a good result at the end. And the framework provider is responsible for making sure that it's fast, that the accessibility is good, all of these kind of difficult things, and it's kind of like hidden away. And that's what I think Quick and Builder are trying to achieve, because you're trying to now step up to this next level of the front-end framework is no longer this monster that you have to wait for, but actually it's lightweight and it can land. And I think that what Cloudflare is trying to achieve on the back end is you don't have to think about where you're going to deploy this stuff. You don't have to worry about how many containers you need to buy. It's going to scale out. It's going to be really close to the client, so that the latency is going to be low. You don't have to think about when you hit deploy, like which zone it's going to get sent to and all of this kind of stuff. And I think that the next level, and that's all available right now, right? But the next level is more, okay, I want to push some data into the cloud, and I don't really want to care where it is and what the behavior of it is. I just want it to be there when I need it. And as a developer, I want to be able to just kind of allow a tool like something that Cloudflare produces or someone else that just makes it work well for my situation and uses good heuristics to give me that. And if you can get that to work, then obviously the big players are going to want to do that. And many of the big players are kind of working on that for themselves right now. But if you can make it in a way which is open and to everyone, then there's no reason why someone who just wants to write a small blog wouldn't make use of that. And then instantly they have a very fast internet experience for their readers. They can deploy it. It's cheaper because they're not having to use loads of extra resources that were wasteful. And so everyone wins. And that would be the long-term goal. And I think that there's kind of like steps along the way, and we're some way in there. Some things still need to come. It's like me saying, is the Quick framework production ready? Well, it definitely works, right? I've built things with it. Is it ready for like everyone in the world to just instantly build their blog on? I can ask you that.
I mean, yeah, but you probably want to be, any new framework. I think the big thing is, if you're a junior developer who needs huge docs community ecosystem, no. If you are a company, and this is probably similar to what you're saying, if you're a company that's like suffering from this problem and you can use something newer and maybe deal with a unforeseen issue or two, or like an undocumented thing or two, yeah, it could be fantastic. But sorry for jumping in.
No, I wanted you to jump in because like that's exactly what I'm getting at, is that that there's layers of availability, and the more pain you have, the more it's going to work for you. The less important it is to you, the less you're motivated to use it, right? But the long-term goal is to make it available to everyone easily and freely.
Yeah, and Mishka, I have this weird question for you, which is, because I'm still trying to figure this out myself. I can't entirely put my finger on why Quick has ended up so well suited for all these unexpected and emerging use cases. If I compare it down to two philosophies, but I'm curious your point of view. Philosophy of one is you make stuff faster by doing less stuff. It's not magic. It's just do less things. If you're doing things you don't need to do, find a way to not do the things. And two, it's just this very sort of working backwards from HTML approach. And that just seems to actually have worked so well for all these new things. But what do you think? Like, I'm always surprised a new thing comes up and we're like, oh, wait, Quick is perfect for that. And maybe that's by design. Like maybe Mishko sat down at the base of a mountain, figured out the future of the next 20 years and how to solve for it, or maybe something else. I'm curious what you think.
No, I think it comes down from, I did not sit at the base of a mountain. I'm surprised as much as you are about these things. No, I think it comes down to the fact that it's, this is what we mean by like HTML centric or HTML first, right? Because on the end of the day, like if you think about a normal application, you can't just give somebody a piece of HTML and be like, here you go, that's all you need. It's like, no, that's not so simple, right? Like you need the code, you need JavaScript, you need these things, and everything has to load in the correct order, and like it's complicated, right? Whereas Quick, it really has been designed from like this first principle of like, no, HTML is the kind of the source of the truth, and then you walk backwards from that because, well, HTML is the thing that we send to the browser. It's the thing that we serialize the application and how we communicate. And if you look at existing frameworks, they almost treat HTML as this annoying thing that they wish they didn't have to do, right? It's like, yeah, at the end of the day, we'll write to the DOM and update some stuff, but like, it's kind of this annoying side effect that we have to do versus taking it out as a first order thing and be like, no, HTML is the truth, and we walk backwards from that particular thing. It is a different way of thinking about it. And it's also not only a different way of thinking about it, it's also extremely difficult to actually explain the nuance between it to people. But like once you get it, all of these other use cases become possible, right? The reason why the edge case, the multiple edge servers example works so well is because each edge server just produces a fragment of HTML, and that fragment is fully contained, right? It is sufficient to just take that fragment and inline it to another application and everything works. If it would be any other way where the fragment would say like, well, I need this, but in the head I need the script tag, and then I need this thing, and like it would be complicated, right? And so what makes it kind of powerful is that it's just the HTML, and that HTML contains everything that is needed to resume the application. And yeah, I think that's kind of the long-winded story to it.
You know what's funny too is Dan Shapir had a funny tweet, and he's not wrong about it in one aspect that we I think recently totally discovered, but he said something about like serialization with Quick is a huge benefit, but comes with a slight cost, just like you think about serializing, transferring across workers or something, right? Like your main thread to web worker, there's a small serialization cost. Most use cases, are benefit. The cost does not outweigh the benefit, but some certain use cases, yeah, maybe it will. But what's super fascinating here is I was thinking about that, and there is a slight SSR cost of serialization. In fact, we discovered when we first ran benchmarks on the original implementation of the client-side rendering and the server-side rendering, client-side rendering was 100 times slower than the current frameworks, and now it's equal speed. In fact, I think it's right around Preact levels. We're just ironing that out now. So again, we're taking the learnings from we can call it prior generation, current generation, whatever. We're taking learnings from the state of the art and work it into the new approach, and it does work. And SSR, we're getting it to be a really great speed now with a slight serialization cost, but still much better than like a React or something, right? We're trying to get up to like a Marco, but Marco is insane at how fast it is. But what's funny is that the Dan tweet really made me think like, no matter what, if you're transferring something over the wire to someone else, it is a process of serialize and deserialize. The thing is, the way that we're deserializing now is insane. Download tons of JavaScript and run a ton of code to recover a state is like the most absurdly inefficient serialization format you could ever imagine. Maybe I'm exaggerating, but obviously I'm kind of on one side of the fence of sort of what we think the ideal approach is here. And when you really just think about it as, look, we're just transferring a representation across the wire and we need to pick up in the most efficient possible way, maybe that's the simplest distillation I can think of. And Mishko, I think you want to butt in anyway.
No, I love your comments. I think you have to look at historically how we got here, right? And I can't speak for other frameworks. I can speak for AngularJS. Like AngularJS meant to be a SPA, right? Single page application, right? To a large degree, I was inspired by Gmail. Like, oh my God, Gmail, it all runs in the client, right? No server-side refreshes. It's just an app in the client. It runs all the way through. And so with SPA, like there's never really this idea of server-side pre-rendering. That's just this weird hack that we put afterwards, right? Once we started using SPAs in places where we should have really been using MPAs, right? we discovered that like we love the component way of building things. We love the fact that all the code is in one location. We love all these things from a DX point of view, but the UX is horrible. Like it's way too slow for vast majority of people, right? And so a server-side pre-rendering and then what we call hydration was really a stopgap measure for this particular problem. Right? This wasn't never ever like nobody set out to say like, oh, I need to design a system, and so let's design this server-side rendering and hydration as a solution to this particular problem, right? It was more like we had the SPAs, we were already in love with it, we loved them so much, we dragged them into the area where arguably they shouldn't have been. And then we were like, okay, so what can we do to mitigate this problem, right? And so server-side rendering and hydration from that point of view is really just mitigation. It's not actually the way it is designed.
Yeah, that's so funny. And it's funny too, because I remember talking to Mishko in the really early days of Quick development, and purely just sort of that idea of love it or hate it, HTML is our format. That's how you deliver something declaratively to the browser. So we need to think about it more like how people use JSON today, as just a data serialization format, not as a application format per se. But I agree with you, sort of working backwards. I mean, I remember it too. We had built a large AngularJS application for shop style. And it's funny, actually, we were doing this with, I don't even know, I forgot, Mishko, if you even know this. We needed server-side rendering. We needed better performance for the initial sort of FCP. We didn't use that terminology back then. I don't even know if it was popular back in 2013, 2014, or if it wasn't terms our team was using at the time. We just wanted people to see stuff faster, right? And second, we needed a better crawl speed. And so what we did is I wrote this simple compiler. It was built out of regexes, and it worked surprisingly well to transform AngularJS templates to handlebars templates. You could execute the same code if you just created the same data tree. So imagine what would the minimal data you need on essentially your scope or even root scope, produce that and pass the handlebars template and transfer. Because it is like the logical conclusion. Oh, there's this thing that runs in the browser. Well, I just need that thing in HTML ahead of time. So you do it. Funny enough, AngularJS, was not obviously built with this in mind. Funny enough, what happened is when we tried that on real users, the hydration time or DOM clobber, like the essentially reconstruction of the application time, was so noticeable, like they would be kind of frozen for a while. So we actually canned that and used it for crawlers only, and then just full SPA for the others. And when Angular 2 came out, the Angular Angular non-JS doesn't make sense. Whatever. Angular came out.
Angular.
Just Angular. When Angular came out, we moved to that, and that was an improvement. And then obviously, I mean, Mishko, you dealt with these challenges and probably may have been frustrated because I'd imagine, I mean, you tell me, I don't even know if we ever talked about the origin genesis of Quick, but I'd imagine it was all kind of on this point of like people were demanding certain use cases out of the framework, that the framework, it was just so hard to retrofit into the framework, and why you have this point of view of the challenges others would face. But you tell me if I'm wrong, actually. I'm not even sure if I've even asked this before.
Looking for the unmute button. Okay. So, yeah, I mean, the origin. So Google has a super successful, internally successful framework called Google Wiz. It's not available externally. And, Wiz was basically designed with one thing in mind, which is like, how can we stream data to the client in the fastest possible way and minimize the amount of startup cost? Wiz came actually out of this thing called Google Circles, I think it was called. Remember that thing? And they had a problem that they built this humongous application, and it took forever to wake up, and it was not performant. And so Google Wiz was kind of the answer to this particular thing. And they basically threw out everything, and they just said, like, all we care about is startup performance. And where do we end up, right? They just blindly went with it, and they ended up with this thing called Google Wiz, which is actually now powering Google Search and Google Photos. And I'm always impressed just how fast Google Photo and Google Search is. And so that kind of defined the problem space for me. And I wanted to see, like, can we build something like this in JavaScript? Wiz is kind of a mix between Java and JavaScript, and it's kind of complicated to use. So I don't think in its current form it could ever be accepted by the external community. Also, Wiz was written in days of like pre-imports, etc., and so its syntax is kind of arcane by today's standards, but like, there was no other option back in the day, so it's hard to blame them for that. So I wanted to see, like, could we have basically a beautiful DX experiment, beautiful thing that outside world could accept as saying like, hey, I could totally go with this, right? But at the same time, get the performance that Wiz has. And kind of this was the origin story. And at first, I pitched it in like 2019, I think, in NGConf on the keynote, and I kind of explained like, hey, like I think we should do these kinds of tricks, and I even called it resumability, etc. And it went from there, and that's kind of the origin of it. Yeah.
I think it's just amazing when you think about the history of the web, how we've oscillated between like different ways of doing things. So like the first web was very HTML specific. It was just downloading data, rendering it or whatever. And then people wanted to start getting in like interactive. So you had like backends that would render HTML on the fly, but then that was just becoming too chunky and slow because you had to go back to the server all the time. So you started adding bits of client-side stuff in. And then we went like, let's go fat client. So things like Flash and Silverlight and all of these other tools started popping up. And everyone was really excited about how, oh, brilliant, we can actually build like really big apps in the client and we can actually download it into a browser or whatever. And I guess Java was kind of forerunning that as well with, what were they called? Java things that ran in the browser. Anyway. Anyway, I saw someone in the, what?
Applets?
Yeah, Java applets, right. So this is all kicking off and it was getting really exciting. But then, of course, we realized that this was not really very compatible across different architectures and so on. And so JavaScript came along. And so then we flipped over to JavaScript, and that was great for a while. And we were chucking loads of code down onto the client and making these big JavaScript apps. And now we've realized that actually, the cost of actually downloading these apps on the fly is too great. So we're now pushing back again. But the thing that I was just thinking, it's just really amazing, is like we've basically gone full circle back to the very early days where HTML was the key, right? And it was the driving force behind the web and what was being rendered. And we've kind of gone back to the days where HTML drives everything, and then we add the interactivity around that, rather than the app just happening to use HTML as its kind of output rendering. And it blows my mind that something that could have been devised in the 1980s, like some 30 years ago now, is actually still like right at the front of what is driving the web forward. Just wanted to have that little diatribe from this feeling.
Yes, in that sense we are, but like, I also want to point the counterexample that like it's not the same way, right? Like the DX experience is way better. The way we got stuff back in the day is we had some server rendering string concatenation system, and then we had jQuery on the client, right? And because we had two different systems, these things would always go out of sync. It was hard to keep them in sync. And as a result, the kinds of complexity you could build was limited, because sooner or later the syncing process would get you. And so this is basically how Amazon still builds their site, because it is the fastest way to do it, right? Like nothing beats string concatenation on a server, and nothing beats like augmenting the behavior on the client, right? The difference is that with Quick is that we said like, look, you can have all this, but you can have it in a DX that you're used to, right? That's the value add, right? So like, yes, we're going back in like how it looks like on a wire, but we're not going back in terms of the DX that we used to have, right? Like we're getting the DX we love, and we're getting the performance that we used to have.
Yeah, and that's the thing that moves it forward, is like, and I think we mentioned this right at the beginning, like the developer experience is to some extent as important as user experience, because if the developers can't build things because it's too complex, then the users lose out, right? And I know that you shouldn't say, hey, I'm going to just go developer experience over user experience, because that's where you end up with like where we were at with the big sort of Angular-y, React-y kind of situations. But at the same time, if it's my understanding is that Wiz is not the most developer-friendly environment to build in.
Correct.
And I think that is, is probably one of the reasons why it would struggle if it came outside of Google, because people just would be like, there's so much I have to get my head around to even like build a simple app with this. And so we've got to balance those things out. And I think that's a really key part of a framework builder's job.
And, Wiz and Quick actually, attack the problem. They attack the same problem, but they attack it in very different ways. I don't think a Wiz developer would look at Quick and recognize anything, and vice versa. Mainly, for example, Wiz doesn't really, if you squint, Wiz has resumability, but it doesn't really, because it actually, there's, on a server, it runs Java, right? So like, you're not resuming Java on the client. That's not how it works. Instead, the Java is responsible for creating the state in a form that the client can instantly use and continue. So it's kind of like a precursor to resumability. Like, it gets you the same exact effect per se, but it is not like in the strictest definition of sense resumability, because you're certainly not resuming Java application in the client, or that's not how those things work.
Yeah, this stuff is wild. I think we may have accidentally, partially my fault, teetered from the web worker topic or the edge worker topic. So I hope nobody minds. I think it's a really fascinating thing. And I think this was helpful for my mental model, especially thinking like, okay, a framework like Quick can serialize specific chunks of applications as self-contained resumable units. And then what Cloudflare is working on with multiple edge workers can then do ridiculous orchestration capabilities for faster, more resilient, more personalized applications. It is quite fascinating. It'll be really exciting to see Marco, Astro, maybe others explore this. In the chat, people mentioned things like, there's also things like Live View and HTMX. There's a lot of things going on in this space. Pete, we're going to be really excited to see sort of as you continue to explore. I've heard of some really cool demos that people are working on. I think we'll showcase this, and I think I'm most excited to see some. We have some pretty big names exploring this pretty realistically, but a very large company takes some time to spin some things up. There's more to do there. So those will be exciting. So I think we've got some demos that'll be coming out. We'll be sharing those, and really can't wait. We actually know one on our side that pretty good size e-commerce site moving over to Quick. And be interesting to start working in some of this edge there and working backwards too. So thank you so much, Pete, for coming on. This was a blast. If you want to give any parting words for us besides this was awesome.
Thank you, Steve. It's been really good fun getting back on the podcast circuit, as it were. And it's always fun chatting with both of you. So thanks for having me on.
Thanks for coming, Pete. I'm excited because I love when different people are nibbling on the same exact problem from different directions, right? And so both us, we see the problem, Cloudflare sees the problem, you guys are working at it from the edge worker, we're working at it from the framework side of things. And it's just really heartwarming to see there are other crazy people in this world who see the same thing you see and are going after it. So it provides a way, a form of validation and excitement. And so I'm really looking forward to the demos you guys come up with.
Definitely. We'll have to get back on.
Yeah, this will be fun. All right, we'll close it out here. Thank you so much, everybody, for watching. Thank you, Pete, for coming on. We will catch you all next